Hi there, my name is Barry O'Neill. I'm a Senior Curriculum Engineer here at MongoDB. You may recognize my voice from some of the videos on the university. That's where I spend most of my time. And this talk is about automating Atlas VPC peering with Terraform. And we're going to be using AWS for this talk. So let's have a look at the agenda, what we're going to cover. We're going to first have a look at what a VPC is. We're going to have a look at why you'd use a VPC. We're going to explain VPC peering and why we'd want to use VPC peering. Then we're going to jump into the Atlas UI and the AWS console, and we're going to configure a peering connection from Atlas to AWS. And then we're going to jump over and explain Terraform. We're going to do a brief introduction to Terraform, explain what it is. We're going to go over the new Atlas provider and explain what that does. And then we are going to deploy an Atlas cluster with a peered connection using Terraform. So what is a VPC? A VPC stands for a virtual private cloud. And it lets you provision a logically isolated section of the cloud in a virtual network that you define. What that basically means is you can get your own little private chunk of AWS's bigger public cloud. We obviously wouldn't want all of our instances to be able to be accessed by everyone who has an instance in AWS. So VPC is a nice way of logically isolating all of our instances into their own subnet. And obviously the benefit of that, or one of the features of that, some of the features of that, are that we have the ability to specify IP address ranges. We can pick what IP address ranges we use within that VPC. We can create subnets within it, and we can configure route tables and network gateways. And we're going to be doing exactly that today. We're going to configure route tables from our AWS VPC into our Atlas VPC, and then we're going to add a network gateway to our VPC as well, so that all of our hosts that we deploy can communicate with the external internet if they need to. So we're going to be dealing with two VPCs today. First one being our Atlas VPC. And the Atlas VPC is created when you create your first cluster inside an Atlas project. And each Atlas project has its own VPC. You can choose a range of IPs or a sitter block at the time of creating your first cluster in an Atlas project. If you don't, Atlas will pick a range or an IP range for you. And the reason I mention this is because once you create your first cluster and you have a sitter range assigned to your VPC, it's immutable. You can't change it. So if you want to have a specific IP range defined for your Atlas VPC, you need to make sure that you think of that ahead of time before you create your first cluster in your project in Atlas. And the second VPC that we're going to be working with is our AWS VPC. We're actually going to create one of those shortly. And the AWS VPC obviously is what we mentioned before, is inside the AWS public cloud. And you can see here in this diagram that we have an EC2 instance deployed inside that VPC. So the advantages of using VPCs. Obviously, you're able to choose your range of IP addresses, as I said before, and you can assign those IP addresses to instances inside your own VPC. Security is one of the major reasons you would use a VPC. You can assign a security group, which is another name for a firewall in Amazon or in AWS, to your VPC. And within that security group, you can define rules of where you can have either a range of IPs, a single IP, specific protocols, and all of that you can define who is able to access your VPC. And the reason for that, or the reason we want to do that, is obviously because we don't want anyone who shouldn't have access to gain access to our network. You should always keep the range of IPs small or limited to a single IP, because you want to limit the attack surface of anyone that's trying to access your network. And you can also create dedicated instances. So if you create a dedicated instance in Amazon or in Atlas in this case, you can isolate those inside your own network, which is always a plus. So we've discussed what a VPC is. We know that now. What is VPC peering? VPC peering is expanding your network's boundaries to include another VPC. So in this case, we're going to be peering with a third-party provider, which is AWS and Atlas. but you could set up a peering connection between two VPCs inside AWS as well. It just basically means that every host inside that virtual private network can communicate with other hosts in the other virtual private network over private IPs. So we don't have any information or any traffic going over the public internet. And this is what we're going to be deploying today. We have our Atlas VPC on the right-hand side with our Atlas cluster inside, which is a 3-node replica set. We've got our AWS VPC on the left-hand side with an instance deployed in it. And then we've got our paired connection, which is the bridge connecting the two of them so that any traffic that comes from this instance, this application server, to your Atlas host is over private IPs. So let's have a look at a data flow diagram of Atlas deployment without VPC pairing. You can see here that we've got an application server. Your users are going to submit requests to the application server, depending on what application you have. That request is going to go over the internet and it will arrive at your Atlas cluster, and your Atlas cluster will handle the request for data, the queries that come in. It will send the data back over the internet to the application server. And this is all encrypted over TLS, which is standard in Atlas. You can't disable TLS, so everything's encrypted over the wire. And here is an Atlas deployment, the data flow diagram for an Atlas deployment with VPC pairing. So you can see these two boxes within the larger cloud. We've got an application server here. We've got our Atlas cluster here. And similar to the diagram we saw previously, these are our two VPCs that we're dealing with today. And the application server is able to communicate with our Atlas cluster over private IPs. So in the previous diagram, you could see that the traffic from Atlas to the application server was over the internet. But here, the traffic from the application server to Atlas and back is over private IPs in our VPC, and it's encrypted. So it's an added layer of protection. There are certain steps we need to take to configure VPC pairing. And the first, obviously, is we need to have an organization and a project. Once we have an organization and a project, we can deploy a cluster. After we've deployed our cluster, we need to create a VPC in AWS. If you have an existing VPC, you can use that also. But for the purposes of this demo, we're going to create a VPC to show you how you need to configure it to get this all set up. You need to initiate a pairing request from Atlas. It's quite easy. You just go to the UI, you initiate the pairing request, and Atlas will ask you for all the details from your VPC, from your AWS account, and you complete it and initiate the pairing request. Then we need to jump over to AWS and accept the pairing request. In the EC2 console, in your VPC menu, you'll see the pairing request come in. You click accept, and then the pairing is active. The pairing request is active. The pairing connection is active, I should say. And then lastly, we need to configure route tables. Without route tables, there's no way for our VPCs to communicate with each other. And you'll see how we do that when we jump into the demo. So let's hop over into the UI and start configuring our VPC pairing connection in Atlas and AWS. In AWS, we're going to use the VPC wizard to create a new VPC. We're going to create a VPC with public and private subnets. So click select. We're going to leave all of this pretty much standard, apart from giving the VPC a unique name. We're going to call it Barry_security. And then we're going to associate an elastic IP for a NAT gateway. The reason we're going to do this is because any hosts that we deploy in this VPC may need to be able to access the public internet. So let's click create. Okay, our VPC is being created, so now we can jump over to Atlas and start to configure the peering connection from the Atlas side. In our cluster view, we're going to click on network access and the peering option up the top and add peering connection. And as our clusters in AWS, our VPCs in AWS, we're going to select AWS. On this form, we're going to be asked for some information. So we need our account ID, which is your AWS 12-digit account number, the VPC ID, which we can grab from the VPC dashboard. We need the VPC sitter block, which we're also going to grab from that dashboard, the VPC region, and then our Atlas VPC region and VPC sitter for Atlas. Once we have all that complete, we can just initiate peering. It will take a minute for Atlas to set up the peering connection, and once it does, we should see a message here to say that we need to accept the peering connection on the AWS side. So now we see the message that the peering connection is waiting for approval. We can jump over to AWS and fix that up. In the AWS console on the left-hand side, you'll see there's a peering connection option. And we can see here that there's a pending access request that's coming from Atlas. We can double check all the information down here to make sure that it's okay. We know it is, so we can accept the request. Yes, accept. And then we'll see in the UI that the request is active. So when we go back to Atlas, we can see that it's still waiting approval. And that's because we have one more thing we need to do. We need to add the sitter block for the Atlas VPC to the root tables for our AWS VPC. So let's do that now. Let's check our root table. We're going to go to roots, edit roots, and then we're going to add our Atlas VPC sitter block. And we'll select peering connection, select the peering connection from Atlas, and save roots. And it's successfully edited. So let's jump back into Atlas and check the status of the peering connection on the Atlas side. Okay, so back in Atlas, we can see that our peering connection is successfully set up. Just a note that this can take up to 10 minutes to appear as set up in Atlas, so give it some time. How can we test that this is all working correctly? Well, there are a couple of ways. You can go to your VPC and you can set up a host, so configure an EC2 instance within your VPC. Then go to your cluster tab, get one of the host names from your cluster and use dig or hostname or one of those commands to see that the host name is resolving inside your VPC. Now that we've configured our peering connection in the UI, let's have a look at how we can do it in code using Terraform. MongoDB now has an official connector for HashiCorp's Terraform. What is Terraform? So Terraform is an infrastructure as code tool. It allows us to define our infrastructure as code as opposed to using it in the UI or point and clicking in the UI as we did before. And obviously the benefits of that is that code is reusable. Every time we point and click in the UI, if we want to do that again, we have to go through the whole sequence of events every time we want to do it. And obviously if we have large scale deployments and we want to be deploying a lot of clusters, a lot of VPCs, that's less than ideal. It has providers for most of the popular services. In this case, we're using AWS and Atlas, but there are providers for GCP, Azure, all three cloud providers that Atlas uses, amongst others. You can declaratively define infrastructure in configuration files. And what we mean by that is that you can define configuration files which define the infrastructure that you're trying to deploy. It doesn't really matter what order you define the infrastructure in the Terraform configuration files. Terraform will create a plan itself to get the infrastructure deployed. And we'll see that later on when we go and we look at the configuration files and we see how Terraform actually creates plans. So that brings us on to the Terraform MongoDB Atlas provider. MongoDB now has an official verified provider for Terraform, and that means that our provider is officially supported by HashiCorp. Previous to the current provider, there was only a community provider available, which wasn't officially supported by MongoDB, and it wasn't on HashiCorp's official repo of providers. And it allows you to have fully automated deployment of MongoDB Atlas clusters through code. There is also the Atlas API. So you can use the Atlas REST API to deploy clusters. But obviously, if you wanted to use that in conjunction with another provider, you would have to code all of the logic yourself to get your deployment to go state. That's where Terraform comes in. And the API has very, very rich functionality. You can check the API documentation. At the moment, the Terraform provider covers about 75 to 80% of all the functionality of the API, but we're continually adding functionality as we go. So for the most part, you can do most things that you can do with the Atlas API, but there are some limited features that aren't available as yet. So again, as before, this is what we're deploying. We're going to deploy our AWS, or Atlas VPC on the right, I should say, with an Atlas cluster. And we're actually going to deploy a multi-region cluster. So we're going to have a node in each node is going to be in a different region. And obviously that's desirable for high availability, because if one region goes kaput, we know that we've got a node in 2 other regions. And then we're going to deploy our AWS VPC. We're going to create that from Terraform, similar to the way we created it in the UI. We're going to define it all in configuration files and have Terraform do it for us. And then in the middle, we've got our paired connection. Also, we're going to configure that in Terraform so that we don't have to go near the UI to do any of this. So there's some common commands that we use when we're deploying infrastructure using Terraform. This is the help output. There are a lot of commands there, but there are 3 main commands that we're going to use today. We'll start from the bottom up, or we'll start from the middle actually. So init is an initializer. It will initialize Terraform in the current working directory. And not only will it initialize Terraform and let Terraform know that the current working directory is indeed a Terraform configuration, but it will actually download all of the providers that we need. So in this case, we're using AWS and we're using Atlas. So when we initialize in the working directory, Terraform will actually download the Atlas provider and the AWS provider. And the second command is plan. Plan is, as it might sound, it outputs the Terraform plan for the current deploy. Let's say we created a new configuration file and we wanted to deploy a 3-node replica set in different regions with a VPC and a pairing connection. If we create those files, we initialize it, and then we execute Terraform plan, Terraform will output the plan that it intends to use to get our configuration deployed. You should always check Terraform plan before you apply any Terraform configuration, because obviously you don't want to delete or create anything that you didn't mean to. And then lastly is Terraform apply. And as it sounds, Terraform apply is basically the Terraform go button. It will prompt you with the plan again, and it will ask you if you want to execute the apply. And you'll type in yes, and it will start to iterate through all of the steps to get our configuration deployed. So firstly, we're going to initialize Terraform in the working directory using Terraform init. Then we're going to use Terraform plan to output the plan. And then we're going to Terraform apply to apply changes. And all going well, we will reach config achieved, where all of our configuration is deployed in real life, and we can go and check it out then in the Atlas UI to make sure everything's as it should be. And before we start deploying infrastructure in Terraform, there are some things we need. So we need to generate an API key, and we need to generate an API key at organization level. So to do that, we go to our organization, which my one here is named Barry123. We'll click the Access Manager tab and API keys. There's a big green button here that says Generate API Key. Strangely enough, that's what we need to click. And we need to give our API key a name and assign some roles to it. We need to have the project or the organization owner role, the organization project creator role, and the organization member role. And the reason we need these is because we're going to be creating a project and we need to create clusters. So we're going to have to be sure that we have the required roles assigned to our API key so that Terraform can perform all the necessary tasks to deploy our infrastructure. Once you've generated the API key, you'll be prompted to add a whitelist entry. And as we're talking about security here, whitelist entries for API keys are very important. We all know that we should keep API keys secret. They should be treated as a username and password. But as an added layer of security, you should always restrict them to either an IP, which you can add your current IP using the button there, or you can restrict them to a sitter block, which will be inside your current network. So that you know that even if the API keys do get leaked, you will still be in a good spot because only people inside your organization can use them. So let's code. We mentioned API keys previously, and we said that API keys should be treated as username and password. Now there's some secrets that we're using here that really should not be put in plain text in code. Because if you commit these to Git, you could end up with a very, very expensive bill for Bitcoin miners or a very expensive bill for Atlas clusters, which no one wants. Configure your AWS keys using the AWS CLI or as environment variables. Myself, I have my AWS keys configured in the CLI, so I really don't have to worry about them. You should always do that, because if you commit them to GitHub, as I said, it's not a good day. You should also configure your Atlas API key and group ID as environment variables. And this is how you do it. So obviously we're just exporting our AWS secret access key, but the interesting ones here are the Terraform environment variables. If you want Terraform to automatically pick up your environment variables, you should prefix them with tf_var_ the variable name that you've defined in your Terraform configuration. And Terraform automatically checks for environment variables, so it's pretty handy like that, in that you don't have to worry about this. Once you have your environment variable exported and you have the variable defined inside Terraform, Terraform checks and it will pick it up. So this is this file structure we're going to be using today. We have a file called Atlas stuff, which is going to have, strangely enough, all of our Atlas stuff inside it. It's going to have our Atlas VPC, our Atlas cluster, all the peering connection details that we basically everything that we did inside the Atlas UI when we were creating the peering connection, except this time we're actually going to create a project. We're going to create a multi-region cluster. And the AWS VPC.tf is a file that contains all of the details to create a VPC in AWS. Again, it's basically everything that we did in the UI, but defined in a config file in code. And then lastly, we've got our variables.tf. No prizes for guessing what variables.tf contains. It contains a load of variables. And that's where we define all of our variables for Terraform to use in the configuration. So let's have a look at variables.tf first. We'll hop over into the code editor in a minute, but we'll just go through the variables that we're going to be working with. Obviously, our public key is the Atlas public key that we retrieved when we generated our API key. The private key is the private API key for Atlas, both of which we've exported as environment variables. And our Atlas region, we've defaulted it to US East 1. And our AWS region, we've defaulted it to US East 1 as well. Our Atlas DB user is the database user that will be created on our Atlas cluster when it's created in our project. Obviously, we need to have a user that we can log on to Atlas with, and we'll define a name for that user in our code, and we'll also define the password. The AWS account ID is the account ID associated with your AWS account that is going to be responsible for, or we're going to create the VPC on. And then our Atlas org ID is our organization ID for Atlas. I'm going to show you where to retrieve that now in 2 seconds. And then our Atlas VPC sitter. We mentioned earlier on that you can either let Atlas decide on a sitter block for your VPC, or you can define it yourself. So in this case, we're going to define it ourselves. We're going to tell Atlas what sitter range we want for our Atlas VPC. So before I mentioned the Atlas sitter block, I mentioned the Atlas org ID. The org ID is a unique object ID for your organization. It's not actually the name of your org ID. So let's jump over to the Atlas UI and I'll show you where to grab that value really quickly. So we're in our organization view in Atlas, and you might notice that we have all of our projects here within this organization. And up the top in the URL, you can see that there's an OID. And that is your organization ID. That's the value that you're going to need to provide to Terraform so it knows which organization to create the project in. You'll know that you're in the org view because it will be org/ and then this OID. So that's how you grab that value. So back to our Terraform config. We just grabbed our organization ID, and now it's time to have a look at how we define what we want Terraform to deploy for us. In Terraform, we define resources. And in this atlasstuff.tf file, you can see that we have 4 resources. We've got our MongoDB Atlas cluster, which is our cluster that we're going to call cluster test. We've got our MongoDB Atlas database user, which is the database user that we're going to create on the cluster. We've got our network container, and the term container is an interesting one because in Terraform, in the Atlas provider, we refer to VPCs as containers. So don't get the term container confused with a Docker container or a container as in, the Docker sense. It's not. It's a container in this instance literally means your VPC. And then the network peering connection obviously means the configuration on the Atlas side for our VPC peering. There's one resource here that we haven't got on this slide, but we're going to look at in code, and that is our MongoDB Atlas project resource, which is going to create a project in our org ID to contain our cluster. So let's jump over to our code editor and have a look at how this is all defined. Okay, so here we are in VS Code, and we are looking at the Terraform config that we discussed back on the slide deck. So up the top here, you can see that in the Atlas cluster TF file, we have defined a provider, which is MongoDB Atlas, and that's taken the value public key and private key. There are AWS keys, our API keys that we created in the Atlas UI, and we stored them as environment variables. So our first resource here is our MongoDB project resource. We're going to name the project MongoDB Live, and then it's going to take our org ID, which again, we've defined as an environment variable, but if you don't define it as an environment variable, you will be prompted for that value. You can see that we have the org ID defined here in our variables.tf file. So Terraform will check to see if there's an environment variable, and if not, it will prompt us for it when we try to do Terraform plan. Okay, so here we are in VS Code, and we're in our cluster, Atlas cluster.tf file, which is where we're going to define all of the stuff on Atlas side that we configured in the UI when we were configuring VPC pairing from the UI. You can see the difference here is that we're going to actually create a project. We're going to deploy a multi-region cluster all in code. At the top here, you can see we're defining the provider as MongoDB Atlas. That's the provider we're going to use because obviously we want to deploy this configuration in Atlas. It's taking the variables public key and private key, which are our Atlas public and private API keys. We've defined them as environment variables. And our first resource here is our MongoDB Atlas project. And exactly as it does exactly as it says on the tin, it's going to create a MongoDB Atlas project, and it's going to name MongoDB.live or MongoDB-live, and it's going to be inside of the org ID that we've defined as an environment variable. I showed you where to get that org ID variable or value in the UI. You just need to go over and grab that. And then this is our cluster here. So we can define all sorts of values for a cluster. We can deploy a sharded cluster, we can deploy a replica set, and in this case we're going to deploy a 3-node replica set distributed across 3 different regions. So it's going to be called cluster test multi-region. This size is 100. We have 1 shard because it's a replica set. It's not actually a sharded cluster. It's a type replica set. The provider name is AWS because that's where we want to configure our peering connection. So obviously we're going to deploy this cluster in AWS, and we can define IOPS, the volume. Instance size is an M10. That's the minimum size that we can use for VPC peering connection in Atlas. And then the replication specs. So we have a 3-node replica set here. You can define the number of electable nodes per region. So if we bump this up, it would deploy 2 nodes, 3 nodes in the US East 1 region. And we can deploy analytics nodes or read-only nodes. And all the stuff that you can define in the Atlas UI for replication settings, you can define here in Terraform. And then the DB user is simply just the DB user. We're going to assign the roles of read, write, and the admin database. And we are going to call the user Barry, where we've got that defined in our variables.tf file. You can see here, we're calling the user Barry. We've defaulted it to Barry, and then the variable the password is Barry123. So you don't have to be a top range hacker to guess that one. And then we've got a resource which is our network container, which is what we said earlier on, right? We we call a container or a VPC a container in the Terraform provider. So not to be confused with a container in the sense of a Docker container. And then we've got our MongoDB Atlas network pairing, which is all the stuff that we configured in the UI. It's going to take our acceptor region, which is our AWS region, which we have defined in variables.tf. And we have our project ID, which is going to be known after creation. Our container ID, which is our Atlas VPC. Provider name is AWS. Root table sitter block, which is what we need to input into AWS. Our VPC ID and our AWS account ID. So all the same stuff that we did in the UI, we're just defining it in a configuration file here. And if we jump over into our AWS VPC.tf file, you'll recognize a lot of these values from when we configured our VPC through the EC2 console. The provider is AWS, and a region is US East 2, and our shared credentials file. So there are different ways that we can configure our AWS credentials, AWS keys in Terraform. We can define them as environment variables, or we can use the AWS CLI. And with the AWS CLI, you need to just give it the path to your AWS configuration file, which is where your keys are stored. So in this case, I'm on a Mac, so that's the path to the AWS configuration file. And Terraform will pick those up. This is the VPC primary, the primary VPC we're going to create, the sitter block of 10.0.0.0.16. We want DNS host names enabled, DNS support. AWS Internet Gateway, we want to have an Internet Gateway so that any hosts we deploy within this VPC can access the public Internet. So the root table is the same as the root table configuration that we saw created by default when we created the VPC. This is for external access to the Internet. Our AWS root is configuring the peering connection on the AWS side from Atlas. So you can see here that it's taking the MongoDB Atlas connection ID, and this is all the details for the VPC peering connection on the AWS side from Atlas. And similarly, we've got two subnets defined here. And then we've got our security group configured. So we can put any rules we want in here. We mentioned earlier on that we want to try and keep things as locked down as possible. But for this exercise, we're just going to use pretty default standard security group rules. And then this one here is quite interesting. If you remember before, we had to go over to the AWS UI and accept the connection from Atlas. If you want to not have to do that, for want of a better way of saying it, if you don't want to have to do that, you can set this resource here, which is the AWS peering connection acceptor. And if you set auto accept to true, it will take this value, which is the network peering connection, the connection ID, and it will auto accept it. So you don't actually have to go over to the UI and accept the peering connection. So let's have a look at the output of Terraform plan to see what this is all going to do when we actually go to deploy this configuration. Okay, so after a minute, we should see that Terraform will output a plan. And everything that's going to be created is marked with a green plus, and everything that's going to be destroyed is marked with a minus sign, red minus. So we can clearly see if anything is going to be destroyed or if anything is going to be created. And obviously that's important because we don't want to accidentally destroy or create any infrastructure unnecessarily. We want to be sure that what we're deploying is what we actually want to have in our infrastructure. So you can look here, you can see every single resource that we've defined. And if we scroll down, we can see that we are going to be creating an Atlas security group with the following values. We have Internet Gateway. We have our subnets here that we defined. And this is the VPC we're going to create with all the values. And some values are obviously going to be known after apply because they'll be returned from AWS. And we have the VPC pairing acceptor, which is going to automatically accept the connection. And then we have the details of our cluster. And a lot of these values are going to be known after apply because obviously they're going to come back from the Atlas API. And these are all the replication specs. We can see that we're deploying a 3-node cluster. And the DB user is going to be Barry on admin. The password is sensitive, so it's not showing that value, which is good. and we see all the stuff about our MongoDB Atlas network container and all the stuff that basically we defined in the configuration file. So if we're happy enough with that, we can go ahead and do a Terraform apply. After we've inputted any variable values that Terraform asks us for, we will be prompted with the plan again, and we can double check it, and it will ask us if we want to deploy these changes. And obviously we do want to deploy this infrastructure, so we're going to type in yes. And Terraform will start outputting all the current steps that it's taking to deploy our infrastructure. So we'll give that a minute, and then we can jump back over into the organization, and we should be able to see things start to take place in the Atlas UI. So after we execute Terraform apply, we'll get the plan outputted again, just for us to double check and make sure that everything is as it is, as it's intended to be. And we know it is here. We can see that everything that we've defined in our config is what's going to be deployed. So I'm happy enough. So I'm going to input yes here and hit return. And you can see now that Terraform is starting to execute the steps needed to deploy our configuration. So if we go over to the projects tab, we should see that our project is being created. And if we go in, we can see that our cluster is actually being deployed. So Terraform is working in the background, interacting with the Atlas API to tell Atlas that we want to create this cluster called cluster test multi-region, and it is deploying all of those changes. Now it's also going to create the peering connection, because we defined that in our config as well. So if we go into the network access tab and peering connection, yeah, we can see that there's a peering connection created, and it's still pending approval on the AWS side. Now that's to be expected, because our cluster is still deploying here, so we have to wait for the deployment to complete before we'll see everything as it should be in the Atlas UI and in the AWS UI as well. Okay, so you can see here our apply is complete in Terraform. It's given us the output. Let's refresh our UI in Atlas. You can see that it's still waiting for approval, but that's to be expected. It can take up to 10 minutes or so for the peering connection to appear as accepted in Atlas. But what we can do is we can go and check in AWS to check that the peering connection has been configured over there. So we can get the peering ID from here, which ends in FC38, and go over to our peering connection requests and have a look and see if it's here. Now we can see FC38 here. It's listed as active. We can see the VPC, we can see the sitter range, and then we've got the requester sitter range, which is the sitter range for our Atlas VPC, which is here. So that's how we know that it's been successful. In a few minutes, this will turn green, and we'll pop back and have a look. But that's how you deploy a cluster using Terraform with a VPC peering connection in AWS. So while that deploy is happening, one thing that we can do with the Terraform provider for Atlas, which is really useful, is we can define outputs. So let's say we want to get the connection string for the cluster so that we can use it instantaneously after it's deployed without having to go to the UI, without having to copy the connection string from the Atlas UI and go and do all that point and click stuff that we're trying to avoid here. You can set an output, and here we've got the output, which is connection strings, and take the value of MongoDB Atlas cluster.myCluster.connection strings. And once the Terraform apply is being complete, it will output the connection string for that cluster so that we can copy and paste it and put it into our application server or use it to connect using the Mongo shell. It's pretty handy. It's paid off. Looking at the peering menu in the network access tab, we can see now that our peering connection is available. Our cluster is being deployed. Multi-region cluster in 3 different regions. And then if we go over to if we go over to AWS, we can see that our peering connection is active. And that's it for this talk. I hope you found it informative. I just want to give a couple of shout outs to 2 of my colleagues here at MongoDB. Nikhil Singh for his help with the Terraform config. I'm going to link Nikhil's GitHub repo in the original slides. And Melissa Plunkett for reviewing the slide deck and providing me with some very, very valuable recommendations. Thank you very much for listening. And that's it.